Okay, in this second part of the video of transforming the parabola, we're going to look at what adding numbers in in certain parts of this parabola does to the actual picture. So in this case, we are going to add a number uh, after the x squared term. All right, so let's just think about this for a second. If what we're going to be doing is we're going to be plugging in a number, we're going to square it, and then we're going to add 4 to every single output. How will that change how the graph looks? Well, let's actually dig into this and see what we get. So here we've got y is equal to 3 squared, right? X squared plus 4. So 9 plus 4 is 13. Okay, if I keep doing that real quick so you guys can pause the video and put in these numbers. Okay, we're back. So y is equal to, let's plug in a 2, square it and add 4. That's 4 plus 4 is 8. 1 squared plus 4 is 5. 0 squared is 0. Plus 4 is 4. Negative 1 squared is 1. Plus 4 is 5. And I can see that symmetry thing happening in this chart right around the middle part. And I'll just do one more. Negative 2 squared is 4. Plus another 4 is 8. And 13, and so on. All right, so if we draw this graph, put these points on, 3, 13 is going to be 3, 13. What a surprise. I actually plotted it exactly 4 units above what it used to be. Okay, so instead of there, it's now there. 2, 8, I used to go 2, 4. Well, now I'm going to go 4 units above that. 1, 5, I used to go 1, 1. Well, now I'm going to go 4 units above that. So all my points are being lifted exactly 4 units above where they used to be. Even the vertex, okay? So 0 plus 4 is 4, so that goes up. Negative 1, 5. Negative 2, 8. Negative 3, 13. Okay? So what we've got is we have the old parabola that hasn't been stretched at all. It hasn't been stretched at all because it's like a 1x squared. Okay? There's no coefficient in front of the x squared, so it's like a 1. But then plus 4 is going to make all of our y values be lifted by 4. So, it's just a regular parabola kind of grown from a lifted place. So if you want, you can kind of think about this as saying, taking that vertex there, if I know that the vertex is going to get lifted 4, I know my new vertex is going to be right there at 4 units up. And then if I know the parabola isn't stretched at all, from that new location, I can go 1 over 1 up, 2 over 4 up, 3 over 9 up. So it's, the way I look at it is the position of the parabola got translated. That means just relocated. So translated 4 units up, okay, to right there, circled in red. And then from there, we draw just a regular unstretched parabola grown from that vertex. Okay? So that's kind of an easy way to I think, graph these. We can also imagine it, anyway, I'll stop talking. All right, so let's look at this next one and see if we can figure out how to graph it. Well, go ahead and plug in the points, work it all out, do the math, okay? We want to get away from having to do this t-chart and doing all the arithmetic involved and figuring out what the thing looks like that way. Let's instead look at what actually is happening to the picture here. So this is a regular parabola, okay? This half in front means it's going to be sort of half as vertically tall as it was. So in other words, it's been vertically stretched by a scale factor of half. and it's also moved 5 down. Okay? So imagine, let me go back to here, and let's kind of draw how this is going to look. So let me see here. Yeah, let's keep this. Okay, so I'm just going to erase this. So here's a regular parabola, f of x equals x squared. I'm going to put a 1 over 2 in front. So it now is made half as tall as we'd kind of been through before. Instead of 1 over 1 up, it's half the way up all the time. So it's been sort of vertically stretched by a scale factor of half. And then if I go minus 5, the whole show gets dropped down 5. Okay? So that whole picture just went down 5 units. Okay? Let me just keep that half there. I'm just going to change this to a Q. And I've got a little slider that says that when I subtract, 6, it's going down. And if I subtract negative 3, well, if I subtract negative 3, it's going to be like I'm plusing 3, so then it's going up. So let me change that. Actually, let me change that to this. Okay, sorry about that. Okay, that makes more sense. All right, so if I add a positive number, it goes up. If I add a negative number, it goes down. That's what I meant to do, okay? So if Q is positive, it goes up. Q is negative, it goes down. All right, so getting back to our notes then, let's see how we would draw this one on paper. We know it's going to get dropped 4 down, so I'm going to draw my new vertex to grow everything from. I'm going to drop it 5 units down here to negative 5. Okay? Now, from that new growing location, I'm going to grow it vertically sort of squashed. So instead of going 1 over 1 up, I'm going to go half as much up. So I'm going to go 1 over half up on both sides. Okay? The next point is normally 2 over 4 up. Well, I know that the scale factor is a half, so I'm going to go 2 over 2 up, symmetrically on both sides. The next set of points is 3 out, 9 up. Well, half as tall from there is going to be 1, 2, 3, 4 and a half. You'll know you're doing it correctly if the points make this sort of smooth pattern that you can sort of start to see that parabola in there. So let's just do as many as we can do on this grid. 4 out from the origin would be normally 16 up, so we're going to go 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Everything falls in line. 5 over would be 25 up. Well, so that means I'm going to go 12 and a half up. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 and a half. We do it on one side, I do the other. Oops, something happened to my vertex. Okay, so when we look at it all, stand back, we've got this nice, smooth pattern connecting the dots. We had a parabola that's vertically stretched by a scale factor of half, moved 5 down, and looks like that. Okay? So, moral of the story is, whatever that number is being added or subtracted, if we add a positive number, okay, it goes up, translated up. If we add a negative number, we subtract something, that is, it moves down that number of units. Okay? All right, so what we've talked about is a vertical translation. Okay? By the way, that's what this is called. A translation is just kind of like a relocation, and we're talking up or down, so this is a vertically translated parabola. All right, so the last type of transformation we're going to look at on the next page is inside the brackets. Now, this is the hardest one to understand out of all of them, okay? So let's start off with our good old friend y equals x squared. And let's compare it to what if we subtract first before we squared. Okay, so we're going to subtract a number and then square it. All right, so this one here, let's just take a little bit of care and attention the way that we work this out. So here, our output is going to be our input of 3. We're going to subtract 2, and then we're going to square it. Well, 3 minus 2 is 1. 1 squared is 1. Okay? For the next one, our input is 2. 2 minus 2 is 0. Squared is 0. Our next one is 1. 1 minus 2. 1 minus 2 is negative 1. Square it. Negative 1 times negative 1 is positive 1. Plug in a 0. 0 minus 2 is negative 2. Square it, and we get 4. Let's do one more here. Y is equal to, let's plug in negative 1. Negative 1 subtract 2 is negative 3. And if you square that, you get 9. Okay? Let's do one more. Y is equal to negative 2 minus negative 2. That's negative 4. Square it, you get 16. Okay? Let's throw in a 4 here. So if I plug in 4 and subtract 2, I get 2 squared is 4. So you can see the middle has been moved from its normal location. So here's the middle of the chart, right? Everything kind of follows symmetrically around above and below it. Well, if we go back a page, notice that the middle of the chart always used to be when x was 0. Okay? You can go back here, right? The middle was always when x was 0, like that. Okay. Let's go back. I'm just going to erase this. If we go here, our middle of symmetry is now at 2. Well, watch what happens when we plot those as actual points. 4, 4. So 4, 4, 4 over 4 up. 3, 1. 2, 0. 1, 1. 0, 4. Well, visually, the effect of the graph is it's been moving that way. So when you subtract or add inside the brackets, it changes sort of it moves it left or right. It changes the horizontal middle of this thing. Okay, negative 1, 9 is now here. Okay, by symmetry, you could probably figure out that, had we put in the chart 5 minus 2 is 3, also 9. So the long and the short of it is, the parabola got moved 2 units to the right. Okay? So here's why this is a little bit tricky, is we have to see what number's been subtracted there to tell, like, right or left. So since we're subtracting 2, okay, it's 2 to the right. All right, so I guess what I'm saying is it's kind of opposite. Ooh, what happened there? No, did I just close down the notes? 1 second, I gotta pause this. Okay, so it seems I didn't lose anything. Otherwise, you would have heard Mr. Hess openly weeping on camera, or on mic anyway. All right, but everything's good. Okay, so we've moved 2 to the right. So what confuses people about this is the fact that it's being subtracted. Let's do it again. Okay, when we subtract 2, you might in your mind think, oh, that's kind of like left, because subtracting is going towards the left. But if it's minus 2, that's your cue that it's actually 2 to the right. So it's kind of like opposite thinking when it's inside the brackets being squared. So subtracting 2 is moving it 2 to the right. Okay? All right, so for this one here, let's kind of try and do this one without the chart, and let's sort of figure out how this regular parabola has been moved. Okay, so thinking that's, go ahead and figure out and plug in the things in the chart to prove it to yourself. But given that it's plus 1 in there, plus 1 would make me, think like it. Remember, that's opposite land, so that's actually 1 to the left. Because what we're doing here is we're going y is equal to x subtract negative 1 squared minus 4. Okay? So we're going to the left one because it's kind of opposite what you might think inside there, and 4 down. So 1 to the left, 4 down. All right, so our vertex isn't going to be at 0, 0 anymore. It's going to move 1 to the left, 4 down. Okay? So its new location is negative 1, 4. So notice when I write it that way, that's kind of like the x-coordinate of the vertex, and 4 is like the y-coordinate of the vertex. Okay? Sorry, negative 1, negative 4. So it's like those two. When I write it that way, I can just look at this thing and see, oh, the vertex is negative 1, negative 4. If I were to use the original one that I gave you guys, let me just rewrite it over here. So in this question, you were asked to go y is equal to x plus 1 squared minus 4. So the quick way of looking at seeing what the vertex here is going, oh yeah, it's opposite. So the vertex, the x-coordinate is going to be, well, I could write that as x minus negative 1. So I know it's opposite. So my vertex is going to be opposite sign of that, and then whatever that is. So negative 1, negative 4. Okay? 1 to the left, 4 down. All right, so the next thing we have to do is look to see, is there any number in front of there? Well, it's like a 1 because there's no number. So this is just like a regular parabola that's not been stretched, moved 1 to the left, 4 down. So from our new location of our new vertex, we can just grow it normally. 1 over 1 up, 2 over 4 up, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9 up, so on. Okay? So we're just taking our regular parabola and relocating it to its new spot. All right, so putting it all together, because the vertex is identifiable from here as to being what's subtracted. So here, remember, we could write this as 1x minus negative 1 squared minus 4. Well, I can see that this number and this number, p and q, well, actually, let me just go back for a second. Instead of writing plus 4, to make it the same, I could go plus negative 4. Okay, because that's the same as subtracting 4. So looking at those two values, my vertex is P and Q. Okay? Or you can just, look at it in the way that we described it before, or think it's going 1 to the left, 4 down, so it would make sense, And then this is the stretch. So stretch, PQ. If the stretch is negative, you're going upside down instead of right side up. And now that I've just said the last, couple of minutes of sentences there, that all seems confusing the way it came out of my mouth, it's best that on the next video, we do some examples of how to actually use the vertex form of a parabola to graph a parabola.